recording.
Yep.
Okay, so you would put one end plate down and just decide that that will be either the front or the back.
Okay.
And that's important because the back one will have the wires coming out and the front one has to be easy to remove so that you can put the rotor in.
Which one would you choose first?
Well, I did the back one first.
Okay.
So you would lay it down on the table, place the core on it, and then go through and mark the holes.
Okay.
And well, there are some other details. When you put it on the plate, you have to try to center it. It should be like that.
All right.
Like
so
this.
It will be, straight.
Yeah, these tips come right to the edge.
Yep.
Because it's 15-inch diameter,
Mm-hmm.
and it comes right to the edge. But you could take some measurements and line it up so that it's right in the center. And you want to try to get the center hole in the center of the bore.
All right.
And that's a little difficult, but what I did was I made a compass. I put it I had the plate down on a piece of wood, and I made a compass with a nail and a piece of string.
Okay.
And put that in the center, and I just made a circle that was the same diameter as the bore.
Okay, I understand.
In the core, yeah.
Mm-hmm.
So you line it up, then mark the holes.
Drill them.
Take the, pardon me?
Drill them as well.
Yes. Well,
okay.
with the spacers on there,
it's a long way.
It's very long. It's 6.5 inches.
So take off the.
Well, you can't take the. You can't really take the spacers off. Well, maybe you can if it's going to be.
No, I see. I'm saying.
How do you mark?
No, you can't take the spacers
taking
off.
the core and drill right at the marks.
Yeah. Just drill.
Okay.
Mark the holes and drill it. The way we did it was with the bare core, because there's no wire on there, and I actually drilled right through.
How did you do it in Taiwan?
Mr. Lee did it with the long AWL, which is a scratching tool, you know.
So you put the end plate on top of the core and down the.
You put it on the table, put the core down, and no bolts in there. So you have to be careful that the bolts are, so that they don't fall off, because the bolts won't be in there. So you get the whole thing positioned on the table, on top of the end plate. Get it all aligned and centered. Then mark the holes. Take the core off. Drill the holes.
Okay.
And also, well, while you have it on there, you want to estimate where the wires are going to come out. So you would do the back one first. So here's one hole.
Yep.
And this is a start lead. It goes right into the coil right there.
Mm-hmm.
And the other one comes around from over here and comes out here. So there's one here, one there. On this side,
these are from the secondary, from the
primary.
left primary.
Yes.
And these two?
You
secondary.
Can't see in the little ones.
Oh, okay.
There's two.
All right.
Just like this on this side.
Okay. So
There's
these
also,
4 are the primary.
Yeah.
And these 2 and another 2 are from the secondary coils.
Yes.
Okay.
Yeah, so you drill those holes also. After you drill the mounting holes, then you drill those 8 holes.
Okay.
Now you can put that plate aside, but you have to, before you put it aside, you have to mark, make sure where, so you can put it back the same way. You have to make an assembly mark somehow on the pole piece and on the end plate, so that you can put it back together the same way.
All right.
The same orientation.
It doesn't make any difference if these coils are. If you put the core upside down, or Okay.
Those two are the start, the highest ones, this one and that one.
Okay.
And these are also the starts.
Okay. So this has to be on top anyway.
One of these is, you know, one start and one start. Yeah, you can't really see out here, they're connected together.
Yeah.
But one's a start and one's a start, and those two are connected together. But there's really only one way that you can set that up.
So from the two possible, choices, it's one that always.
Yeah, it's just one
chosen.
way.
All right.
This, all you do, it's not as difficult. Not as difficult as it looks, because if you didn't have the end plate on there,
Yeah.
this is where the wires come out of the coil, this is where the wires come out, and this is where they come out. So you just drill the hole close to where the wire comes out.
All right.
It's not hard to do.
Okay.
And also, just to be neat, I also drew a big circle so that all 8 wires would be on that circle.
All right. So
that's just to be neat.
So after we finish with the drilling the first the back end plate, how we go to the other one?
Well, then you would lay down the other plate the same way.
Yeah.
But you use the other side of the coil.
Okay.
Or the other side of the core. And do the same thing. The important thing is that you put it back together the same way as when you're drilling.
Yeah.
Of course, if we had a drill press, you could do both at once. You could do both plates at one time. You could, let's see, can you clamp them? You could clamp them, but you have to make sure that everything is in that when you assemble it, it's in the same orientation. Like if you take that end plate, put it on top of this end plate, clamp them together, and drill them together, you could do that.
Yeah.
But you have to make sure that when you take it back apart, that you put them back exactly where, on the same side, like the same orientation, and the same, the core has to be in the same position too.
Okay. So if we are accurate to the fullest by doing that, the bottom parts will be completely parallel, so that they stand as they should be on the base.
Yes.
Okay.
Yeah. Yeah. So
that's the sequence of the assembly.
Yeah, for the end plates.
Okay.
Yeah.
But we have already put the bearings, and especially the stator and the rotor.
Yeah.
Yeah.
Well, you make them oversized. Make the holes too big. For these 3 bolts,
Yes.
you make the holes too big so that you can move the bearing.
Oh, the whole bearing can move slightly.
Yes.
So
Exactly.
you have the. You mean 1 or 2 millimeters?
What's that?
Is that one like?
Yeah. Yeah, that's even probably too much. 1/8 is probably too much. But yeah, you would make them oversized. And what we had to do in Taiwan is we actually had to slot them a little bit and make them oblong, elliptical.
Oh, all right.
Yeah. But if you get it pretty close when you first put the bearing on, then you can get it just by making the holes a little too big, slightly too big.
Okay.
But if it's way off, you might have to make an elliptical hole. But it's not really very difficult to align. If you get the back one, see if you're facing the assembly with both end plates on.
Yep.
There's a space underneath.
Yes.
And what I did was make 2 blocks that you can put under the frame, and you have to make them just the right height.
Yes.
And I used a couple of shims, shims like pieces of wood like that. So and you can drive them in, and then take the front plate off, and the core will stay right there. Everything will stay right there,
Alright.
because you have,
Okay.
it's jacked up and supported. So you take the front plate off, then you can insert the rotor with the shaft. Insert it right into the back bearing,
Okay.
and you can look and see where the gap is. You know, turn the rotor by hand, and you can see whether it needs to move in the back a little bit this way, a little bit that way. You know, you can actually visualize it.
Yes.
And then, once you get the back part close, you can snug the bolts, tighten up the bolts a little bit.
Yes.
And then you can actually position the front of the rotor with your hand and make sure that you have clearance all the way around.
Yes.
Then you put the front plate on.
Yes.
And do the same thing. You align you can move the bearing a little bit, and you have to keep trying,
So with this way, it's easy to align the back, the first bearing, but the second bearing, you can't see the space between the rotor and the stator.
Right.
So you're a little, you're doing it a little blindly.
Yes. Yeah, but you can feel it. It's not very hard. It's not very hard to do. Another thing you could do is drill a window. You can make another big hole.
Oh, like a witch has done.
Yeah, so you can see it in the front, but I did not find that necessary. If you line up the back bearing first, it's easy to get the front one.
So if you adjust the first one and you tighten the bolts, this is secured and steady, but the other one moves a little bit.
Yes. And you just spin it,
and see if scratches a bit.
Yeah. Yeah, you can. It's not hard to tell.
When it scratches, you move a little bit. Then it scratches the other side. You move again, and you find the center.
Yeah.
And how much is the space between?
10 thousandths.
It's like a piece of hair.
No, so a bit more.
A little more than that.
0.2 millimeters around.
0.2 millimeters. Yeah, it's a little more than a piece of hair. So it's very, very tiny.
Yes. But they make them smaller. Some motors they build with half of that.
Okay.
Half that spacing, 0.1 millimeter.
Okay.
But this one's it's not very difficult. If you set up the back bearing first, by looking before you have the plate on there, you can look
then
and see.
The second one is
The second
okay.
one's not bad.
I got it.
Okay.
So then we put we tighten the 5 bolts.
Yeah, to hold it down
on the base.
Yes.
So
it's 10, but you could do through bolts.
It's 10. Okay, it's 10. Yeah, you're right.
10 lag
I thought it was one long one that goes from the one to the other.
It could be. It could be that way. But we have, these bolts are 8 inches long. It's a pretty long bolt. It's custom bolt.
Oh.
Well, I don't know if it's custom, but they're not as easy to find. The very long bolt is not so easy to find.
But isn't the same length that could fit down?
Yeah. Yeah, you could do that. You could use through bolts.
Otherwise,
it lag bolts.
Otherwise, it has to be a screw for wood.
Yes.
Okay. And it is good for such constant vibration.
Yeah. We didn't have anything come loose.
Okay.
It's not so much vibration down here.
All right.
Vibration is, the bearing takes most of it.
Okay.
The whole thing doesn't vibrate very much.
All right. So it's just the bearings that have
it's
most of the
bearings. Yeah.
vibration. Okay. So we're done with that. Then it comes to placing the capacitors.
Mhm. Yes, and that's
Here we'll have to experiment a little with
Yes.
the combinations.
yeah, the tuning. Yeah.
Oh, we have arrived to the tuning, or we have to make the exciter coil before.
Well, you don't have to. No, you don't have to make the exciter coil before. I did the exciter coil after.
Okay.
After we got resonance.
All right.
Then we built it and put it in there. Of course, we didn't get it to do anything yet
Mhm.
because we didn't know that it was supposed to be high voltage.
Mhm.
As I kept it around. I didn't go over 300 volts with it.
Mhm.
So we never got the exciter coil to work, but we will here. But you can tune it. You can do the basic tuning without the exciter coil.
Okay, and how more or less is tuned? I mean the capacitors.
Yes.
Maybe it's better if you have the QEG drawing, the electrical drawing, to explain this.
You just have
Yeah.
to adjust the capacitor
Yep.
value,
Mm-hmm.
and you have to use the scope and look at where you have the maximum output. You have to look at the output coils. We're also going to look at the primary system and look at the waveform and look at the amplitude.
When
And current.
while we're operating it at certain revs.
Yeah, but you don't need to do that to do the tuning. The tuning you can do just with the output, looking at the output. At the
While
out-
it is idle, or while working.
While it's running.
While it's
Yeah.
running.
You have to connect your instruments, set up the capacitors, and then start it up.
And go up to what? How many hertz?
Well, that's what you're looking for. It's going to be
Oh.
around 200 hertz. Somewhere
Okay.
around 200 hertz, but not exactly. That's what you're tuning for, to find the frequency and the RPM where you have the biggest sine wave,
Okay.
where you have the most output. But you have a fixed load, and then you have two variables, which is RPM and capacitor value. But you keep the same load while you're tuning.
Okay.
And you know, if it's, say you have 0.125, that's going to resonate at particular frequency, and the scope will tell you what frequency it is, or a frequency counter, but we'll probably use the scope. The scope that'll read frequency, right, the one you have? Yeah. So the scope will tell you what the frequency is, and will also tell you, you have to compare. You would write down the data from with that value,
Yes.
and then change the capacitor either up or down,
Oh.
and compare that with the reading you just did. See if the voltage is higher or lower, and
Sure.
then you know which way to go, whether to add capacitance or subtract capacitance.
So after a series of tries,
Yes.
you eventually come up with the highest value.
Yes.
But which value of capacitors and which arrangement do I start with?
Well, let's see. What the ones that we're going to start with. Well, you want to be around 0.125, which is
All in series?
yes. 1.5.
The total value.
Yeah, that's the value that's listed here.
Oh, okay. So that's the start value.
Yes, that's
And
the starting value.
following try is above, and the next one is below.
Yeah, or if you add capacitance twice and it still goes up, then
I
you
keep going up.
keep going that way.
Okay.
Yeah.
It's impossible to go down.
Right. Right.
Okay.
Well, you could go down, but if you do 2 tries, and each one is better,
Mm-hmm.
then keep going in
Yeah.
that direction
Yeah.
until you get to the point where it's less.
Mm-hmm.
Then back up.
Okay.
You know, you get it.
So yeah, it seems easy.
Mm-hmm. Yeah.
So,
not too difficult.
So capacitors are tuned that way,
Yes.
and then
Well, the next thing. The next tuning procedure we have to figure out while we're here. I don't know any more than that. So far.
When in the process are we placing the rectifiers?
Well, we would do that after the tuning.
Okay. Mm-hmm.
That's what I'm looking at right now.
Okay.
And you have
So
to make sure you always have a load.
light bulbs. You said what was it? Tungsten.
That's what I'm doing.
Oh, okay. All right.
If we put the light,
220, 220, 220. So you want to get
What's that?
around 600 volts.
And what kind of lamps are these?
incandescent lamps.
Yes, they're
Incandescents. Okay.
Yeah. This is 300 watt at 220 volt is about 4 amps.
Okay.
So 4 amps and 600 volts. So the reason I select 600 volts, well, it's more than 600. You know, if you keep the RPM down, it won't go over. Is because the inverter will only take up to 650 DC.
Oh, okay.
So
But normally you
Um,
have a larger inverter or transformer.
yes, well, the transformer you could connect directly. This isn't complete. I have to put a rectifier in here.
Okay.
I'm just
Yeah, yeah.
experimenting.
Yeah.
This is what I'm trying to figure out for this weekend.
All right.
So when we start, I can't give you a perfect answer right now, but this is what I was going to start with.
Okay.
I don't know if we can get 300 watt light bulbs. So it might be,
Here or generally? Okay.
Here.
But we'll be able.
yeah, you'll be able to find that, or buy it on the internet, and get them somewhere.
They have at least 150 watts, and maybe 300 watts they have. You know the construction lamp
Mm-hmm.
they have on the floor? The
Yeah.
square one.
Yeah, those halogen.
Yeah.
Yeah, we could probably use those. But we've got 1,000 watts out of it at in Taiwan. So this is what I want to start with, because I'm trying to figure out what the impedance should be to drive the inverter. So I think we would start with this, and I want to consult with some people and see, figure out the best way to do it. There would be rectifier in here for the.
I think about it. I want to talk with you on that, but that you will finish to explain because he need it. But later we can talk about that and can update the information.
Mm-hmm.
So still we're tuning the generator without the coil, the exciter coil.
Yeah, or it could be in there. It could be in there for
So how we
the tuning, but you probably will start without it.
Okay. And then how we incorporate the coil in the whole circuit, how we tune it.
Well, it just goes in series there, and hopefully,
Is it this one?
yes,
Okay.
hopefully 600 volts will be enough to make it resonate. If not, then
So
we have to.
It resonates itself as well.
Yes. Yes, that's what we're told. Nobody's been able to get it to work yet. But we will. We will make it work. Now, I don't know if 600 volts is going to be enough. It probably will be enough to make it work.
Look from here.
600 volts, which comes out from the secondary.
Yes.
Okay.
Yeah, and the reason 600 volts is because that's the maximum we could put into the inverter. But I don't know what the impedance is.
The more volts we produce, the easier the coil will, the exciter coil will resonate.
Yes.
Okay. And what is that trick we do for a few times daily for a week?
Adjust this gap.
Do you have any pictures of this particular, point
I don't think
device?
so. I just used 2 pieces of wire.
Oh, so you just place them apart and you adjust the distance?
That's what I did, yes.
Oh, that's simple.
Mm-hmm.
And where do the... it's just
Well,
a
just
wire?
a terminal strip. Just a strip with, terminals. You put wires in and turn the screws. The terminal strips.
Okay.
Or you put the wire in here, put a wire in there, and turn the screw.
Yeah.
Yeah, just one of those, and you connect the wires from the coil and from the capacitors, and then just two short pieces of wire, and bend them and set up a gap.
Oh.
And then Witz says the procedure is that you just run it for maybe 30 minutes and adjust the gap so that it sparks for 2 or 3 seconds.
It sparks, it makes an arc.
Yes.
Okay.
Yes, for 2 or 3 seconds, and then pull it apart. Of course, you stop it first and then pull it apart. Don't ever touch it when it's running.
Okay.
Don't touch anything when it's running.
Mm-hmm.
You will do in your short.
Yeah. Yes.
So you do that for how many times daily?
What did they say? Right in the middle here. Spark for 2 or 3 seconds while tuning. For the first couple of weeks.
How many times daily?
He doesn't really specify. 2 or 3 times. Well, probably 4 or 5 times in half an hour.
Oh, okay. All right.
Yeah.
And then after a couple of weeks,
Yeah.
you finish up.
After a couple of weeks, you're finished, and you can actually. He said you can take it off, take it out.
Which one?
The exciter coil. Don't use
Completely?
it anymore. Yeah.
This means it conditions the circuit somehow.
Yes. Yeah, their video.
It's so
It's not in there.
magic,
Well,
the whole thing sounds so magic.
It sounds magic, and at first I thought that it was a hoax, this exciter coil, but it's not. It really works. It really does take energy from the atmosphere.
So exciter coil does not stay with the generator. It's just for the
Just
tuning
for
part.
tuning, yeah.
Okay.
Yeah, temporary, and then you take it out, jumper across.
But you would have to, if you move the generator, you'd have to use the exciter coil again, yes?
Yes.
Oh, it gets
Because it tunes to the particular
detune.
pattern of energy in that spot on the earth.
Oh.
And that's not all. Sebastian.
He processes the environment. He constrains the environment.
The environment that you're in, the area that you're in has a particular frequency of pattern between the earth and the ionosphere.
Yeah, and the ley lines.
Everything is it's all different. So if you have the generator tuned in one spot and you move, you have to retune it.
Okay.
And you have to use
Same
the
procedure,
exciter
huh?
coil again, right?
Yes,
Okay,
yeah.
so that's,
Same-
same
same
procedure
Okay.
in different locations.
Yeah, and you know, I was saying that talking to people fills in the blanks and gives you pieces of the puzzle. Last night, that conversation with Sebastian, again, was very, very valuable because he said that Sir T told them that you can put the exciter coil in the primary or
In
the secondary.
primary?
Yeah, and that you can ground. See, he also told me there's a ground network. So you actually ground one side of the load. The low
Okay.
side of the load actually goes to ground, a grounding rod that you drive into the earth.
We have no choice in a way to ground the generator in the air. It's the law in many countries.
So you can, and it increases the output, it stabilizes the output,
Oh,
and
that's good.
apparently the input. You know, Sebastian said that
So
Wood said it could be the
that's
input or it could be the output.
That's a relation with the ionosphere.
Radiation?
It's a
Yes.
relation.
Or relation?
Can I,
Yes, yes.
can this
I
be
think that
a little
that's,
secret
with this
of the 40
Yes.
kilowatt?
Do some
Yes.
tests at home with that.
Yeah.
Yes.
Well, yeah.
Something.
That's the effect. Is the output
Tesla
increases.
magic.
Mm.
And he said it can take off suddenly, so you have to be careful. It can increase a lot suddenly,
That's right.
Oh,
and that the grounding
That's,
stabilizes the signal.
that's very significant what Dennis is saying too. More, for me, it's more ethereal and understandable. The relation, that's the relation between the Earth and the ionosphere. Can you expand that just a little bit so we understand more? Like, can you get pictorial with
Yeah, I
it?
told you we were talking about the other day. Danny and I were talking about that effect of grounding, and
Yeah, can you talk a little more about that?
yeah. Well, what were you saying?
Okay, but I was do experiment with I did the experiment with the Tesla coil from a kit about with from Mr. Miel, Professor Konstantin Miel in Germany, and I do experiment and I have to ground one of the line, ground it, and after some time it seemed that the environment, the air, I don't know exactly what, it seemed to be conditioned. And then I can reduce the power of the emitter and still receive at the receptor.
That's beautiful.
Mm-hmm.
Yeah, the
But
environment gets
that's-
conditioned.
Yeah, and that is a relation with the ionosphere. Tesla said this incandescent wave, scalar wave, through
Right.
through the atmosphere, and it's in resonance. When it's come in resonance, it amplifies itself around the Earth. So,
Scalar
So
wave is
you're
a very
just-
large scale resonance.
You're
very
just
large.
entering this constant flow of energy is what
Yes.
you're doing.
Yeah,
You're tuning things up.
putting feelers out there. and
Yeah, you
pulling
put
some
feelers
in.
out there, you plug them in, you ground, and you just go into this wave that is the ionosphere or the space between the Earth and the ionosphere.
Well, that's the energy storage.
yes.
So that's where that
It's a
wave
big
is,
capacitor.
right? It's a big capacitor.
Mm-hmm.
So you're just like joining
Yeah,
that.
the wave is bouncing.
Yeah, a very large scale.
It's a large
Wave.
sine wave, it goes like that? Or,
I don't know the form.
No,
I don't know the shape.
or a scalar is getting bigger, right?
Yeah, or smaller.
Or smaller.
Right, yeah. But I think it's usually used to indicate getting bigger.
So once you get into that energy field between the Earth and the ionosphere, that's where you can work with your devices to amplify. That would be the
They
scalar part of
They
it.
call that amplifier antenna.
Mhm.
But I don't know exactly how it's work. I have to do some experiment. I see something interesting,
Mhm.
but I don't have the equipment to really see what happens in the waveform.
So what is in the ionosphere? Anything? Or is it just a demarcation point?
It's the
Well,
rebound.
there's a barrier. The ionosphere is ionized, which is, an ion is an unstable atom, right? It's missing.
Yeah, it's act like a rebound. The wave rebounds on it.
Okay. So it's just like a field of ions.
Yeah.
Okay, I know what
And
ions are.
in radio work, like even CB or amateur radio, you have a thing called skip. So like we could talk to someone on the other side of the planet by means of skip, because even if it's not line of sight, you send a signal up towards the
Right.
ionosphere and bounce it
Right.
off on the other
Right,
side.
right.
And I've done it many times.
Okay, but this type
It's
of
short wave.
energy,
Oh.
this type of energy is very powerful that we're doing here. It's different than
Different than that. That's
than that.
transmitting a signal. What you're
It's
doing
bouncing.
is
pulling
pulling
in
in some signal.
signal, you're pulling in
Well-
signal, or you're pulling in that energy.
Energy, yeah.
It's the energy that has been stored between the ionosphere barrier and the Earth barrier.
Right.
And you're just jumping into
Yeah.
that field.
The problem is we don't know exactly what is electricity. It's only a theory.
Yeah.
We don't know what exactly. So it is magnetic field, or it is static charge. It is a mix of both. And how it became a wave?
Yeah. Yeah, you can't really see it. You know?
Right.
You don't. It's just
Wait.
it's theoretical.
That's it. Theoretical. So some people like Tesla seem to
Visualize.
yes, visualize, understand. Maybe not completely, because he's still on discovery all the time.
Mm-hmm.
Maybe he don't understand it completely, but he can visualize it enough to be able to do application to use it.
Okay, Tesla was hypersensitive, saw more than was there, heard more than was there.
Yeah,
You
he
know,
can
sensed
analyze that
more.
part.
He had some special ability where he was over, absorbent of these forces.
Mm-hmm.
He was a really a guy who can analyze things, but very deeply.
He was also a very
Mhm.
severely disciplined man
Yes.
in his habits and his lifestyle.
Mm-hmm.
And he prided himself on that too, tremendously. He thought that that was really the way to a higher life, better way. So if we're to think like Tesla, we have to imagine, everything that he imagined. So much energy everywhere. And how did he think? And he's got all these inventions, not just one or two. He's got like hundreds of patents that they took from him that we use today.
Mainstream engineers look at this kind of stuff and they say,
Yeah.
what are you talking about? That can't happen.
Because usually people, when they don't understand something is out of what they have learned, they close their mind. They cannot
Yeah,
work on that anymore.
the belief systems are they really dictate our actions so much. That's why we're stepping outside of the box, and that's why we're working so hard and we're pushing, because we know that we're getting supernatural help, because the universe must evolve in goodness and life, or else I don't want to have any part in it.
Yeah. We talked about the steps of the tuning. So
Yes.
we suppose we finished tuning.
Yes.
So now we want to operate to the RPM, which will always
Yes.
be working. What do I do? What do we do?
When you're tuned to the peak of the fundamental resonance point, you have to find the fundamental frequency. And once you're tuned, the RPM it acts like a phase lock to some extent. It wants to stay in one place. Mechanically wants to stay at that certain RPM.
Is it a specific RPM or it is an area?
An area. That's part of the tuning. It's not going to be the same RPM
Oh,
on this machine, on that machine.
it
It'll
is
be a
about
little different. Yeah, about the same.
and how much? 2,000.
It's less than 3,000.
About.
My little blue notebook there.
Do you feel when you arrive to that RPM and it locks itself?
Yes, you can tell. You can tell because very slight. If you try to speed up, very slight increase gives you more power.
Oh,
But it doesn't. It doesn't change speed very much. But if you're not on the fundamental frequency, it changes easily. The speed changes easily. And then, once you know what that RPM is going to be, then you can use a different type of motor.
yeah.
But that depends on your electronics.
So when you arrive to that RPM and it locks itself, you keep turning the variac till what point? Until what point?
Well, I don't know that exactly.
So do we just see the meter, and if we get close to 10
Here's
10 kilowatts,
This is one.
we're okay.
This is one resonance point that we used in Taiwan.
Taiwan. Oh, 331.
Yeah, and that's with 0.192 microfarad, and the output frequency is 154 hertz. So there's a resonance point there at 154.
154.87 hertz.
Yeah, and then there's another one.
The primary?
Secondary.
Oh, and the primary value, why you put it?
77.32.
77.32.
Yeah, so it's like something like half. Not
What's that?
exactly.
13 times?
Yeah, that's 13 2.5 microfarad capacitors in series.
Oh, okay. That was the initial
Yeah,
assortment you.
yeah, and that's one that we did in Taiwan. And here's really this is the best one we've had so far.
Which one?
That's why I say 0.125,
0.125.
almost 200 hertz, but it's almost 3,000 RPM.
2950 RPM.
So it takes some time to adjust.
196 hertz.
Yeah, there's many resonance points. You have to find
You can have the harmonic,
yes, many harmonics, many.
so you have to find the base.
Yeah.
So we're looking for the maximum hertz.
Not necessarily. You're looking for the maximum
Microfarad.
vibration. The maximum vibration is what you're trying to get.
Oh,
The maximum resonance,
okay.
the maximum sine wave.
And we see that on our meter.
Mm-hmm.
It's the form of
Yeah.
the wave.
Yeah. The amplitude. because it's always a sine wave.
Yes.
But the amplitude, if you fix the load, then you can look at the difference in the amplitude. You know, if you keep the same load all the time, and then you only have two variables, that's RPM and capacitors. But if you change the capacitor value, you change the tuned circuit value, so your RPM will change.
Okay.
So it's those two variables that you have to zero in until you have the maximum amplitude at whatever the capacitor value is.
Okay.
And the RPM is really the main thing is the capacitor value versus the amplitude of the output. So, and it ends up, from what I've seen with this steel, it ends up around 200 hertz. I don't know exactly where. This is where we were in Taiwan. It was 196 hertz, but that 0.125 can be further tuned. You know, maybe 0.120 gives you more, or 0.115 gives you more. So that's why you need a lot of little ones.
Okay.
To fine-tune the value until you get the peak. You can get close and go ahead and use it like that, you know.
Yeah.
But it may not be the maximum.
So at what point we consider we have successfully tuned the generator?
You know.
We were looking
Maximum current output.
for kilowatts or for these values.
Well, you look for maximum current on the output. That's what it seems to me would be you're done tuning when you have maximum output.
Would it be possible that we arrived to a point of getting 1,500 volts at 7.5 amps or something?
1,500 volts, 7.5 amps. Yeah, that may be. Well, it's going to be. I'm thinking that the voltage output is going to be higher than that, the maximum. So
2,000.
Yeah, 2,000 maybe.
And 4 amps, let's say.
Mm-hmm.
But it won't be, a round value, 2,000. It will be
Right.
1,900
Right.
or 2,100.
Right.
Does this make a difference to the value I'm getting out of the inverter? Because that value should be, according to the specs of the local electricity grid.
Yeah, the output from the inverter. Well, once you get the inverter working, you can select the output voltage that you want.
Doesn't matter what goes in the inverter.
Right,
the
right.
output will be according to our
where you set it. It's all electronic.
Oh.
Yeah.
Same with the
Transformer.
transformer.
Yeah. Well, the transformer is not adjustable, so you would have to build your transformer according to what your output is. You'd have to specify what you want.
But since it won't be the same for each generator, we won't be able to have the same.
It should be close.
Oh.
The mechanical, the way that you build the generator and the mechanical setup and the amount of turns and the inductance and all that stuff. Once you have consistency, that'll be pretty consistent.
Oh.
And the variable will then be how much you get from the environment.
Okay.
Because he talks about that. He spent a little bit of time talking about getting the energy from the environment, and he said that the tuning is challenging. So that's once you get all the mechanical things, the electromechanical things tuned up, then you're dependent. Your variable is the exciter coil and your grounding and where the generator is, you know, the location of it. And he said it can increase a lot. He said it can increase suddenly when you're doing that final tuning with the exciter coil.
Mm-hmm.
So, but the building part of it and the mechanical, electromechanical tuning and getting everything set up is going to be fairly close from generator to generator. You know, if you do, if the parts are all similar, it'll be close.
So if it is between 1900 and 2100 volts and 5 amps, let's say, a single transformer would deliver about 220 or 210.
Yeah, 210,
or 30.
230.
Between these, it makes no difference. It doesn't have to be exactly 220.
Well, if you don't have any electronics, you would want to see. You'd have to. It probably would be a custom transformer if you want it to be exact.
Yeah.
You would have to.
We all have electronics in our houses.
Yeah.
You mean to have it a little adjusted?
Mm-hmm. Well, if you're running this generator right into a transformer with no electronics, you would have to. The transformer would have to be wound specifically for the whatever you're putting into it.
Yeah.
But if you have electronics, you can like the inverter we have, you can select with the same input. You can select 110 output or 220 output, 50 hertz or 60 hertz, because it's all electronic processed. But a transformer, you'd have to specify the windings to give you 240 or 220, whatever you want. But you'd have to first know exactly what your input's going to be.
So normally we would need a much bigger inverter than this one we have here.
Yeah, this is a 5,000 watt.
So if we want 10,000 watt, that is probably the cheapest price we can find it anywhere. You have any idea?
Oh, 10,000 watt. The ones I've looked at, I think the cheapest one was about $5,000. But I didn't look at China.